Welcome back to Nelson Network. Today we are going to do subnetting. So we go over what's the definition of subnetting and basic knowledge we need to have in order to do subnetting. And after that, we're going to subnet a lab. We have this lab. We're going to divide this entire topology is in one network currently. We're going to divide it into two networks, as you can see the task here. So we're going to perform that. But first of all, let's go to what is subnetting. Subnetting is a logical subdivision of an IP network. The process of dividing a network into two smaller or more networks is called subnetting. So why do we subnet? The main objective of subnetting is to reduce the network congestion and improve the performance. Also for security reasons. So these are the basic knowledge we need to have in order to perform and understand subnetting. So first of all, we as we all know, we need to understand what's an IP address. It's a unique identifier for a device on our network. So each device we have on the network, whether it's a computer or a printer or a camera or any device that's connected to a network that has IP address, it's a unique identifier for that device on the network. So for example, 192.168.1.10 could be an IP address of a computer. So what is the subnet mask? The subnet mask helps determine which part of the IP address is network portion and which part of that IP address is the host portion. So in this case, for example, this is the network portion and this is the host portion. So for example, you have this subnet mask of 255.255.255.0. The binary notation for this is 1111111 8 1. So each 255 is equals to 111118 times. So which gives 24 octets. If you count all this, it gives 24, 1 to 24, and it gives 24 bits parent, and it gives 3 octets. 3 octet is basically 1 octet is 8 bits. So the ones are the network portion, and the last 8 bits, and which is the last octet, this last 8 bits is the host portion. So this is the case for this subnet mask. It varies. It could be anything. This is a /24. This it could be /25. It could be /16. So it varies. The network ID, another important terminology we need to understand here is the network ID. The network ID is the portion of the IP address before the last host ID that identifies the specific network. So to get the network ID, we set all host bits to 0. So as we said earlier, this is the host. We need to set all this to 0, and when that's done, this entire digits is what we refer to as the network ID. So the network ID is from here, 192 to 1. That gives us the network ID. So the host ID, on the other hand, in order to determine that, this is the portion of the IP address after the network ID. So after this, it's our host ID. So that's it. Now, another terminology we need to understand here is broadcast ID. The last address in a subnet used to send data to all devices in that subnet is called a broadcast ID. To get the broadcast ID, we need to set all the host bits to 1. So with this example, we will set all the host bits to 1. This gives us 255, which is the broadcast address, and that's the broadcast ID. So another useful terminology is usable host. What's the usable host? These are the number of devices, computer, printers, or routers that can be assigned unique IP addresses in the subnet. So every subnet has a specific number of IPs that can be assigned IP addresses. In this case, there's a formula to get the number of usable hosts. Not all the hosts are usable because not all the hosts are free. There are some host IP addresses that are reserved. They are reserved for network ID or the broadcast IP. So the formula to determine what usable host is 2 to the power h minus 2, where h is equal to the number of host bits with value of 0 in the subnet. Why do we subtract 2? We subtract 2 because one address is reserved, as I said, is reserved for the network ID, and one other address is reserved for broadcast ID. So that's why we use this formula. The host ID range. This is the list of IP addresses between the network ID and the broadcast ID. So here, for this example, it's going to be 192.1.1. This one. This is our network ID. Normally, yeah. Our network ID is 192.168.1.0. Between that, we have this. So after the network ID, we have 192.168.1.1. And before the broadcast ID, we have this 192.168.1.254. So in between the network ID, that is after the network ID and before the broadcast ID, we have what is called the host ID range. So yes, so that is it for this basic overview of subnetting. In the next lab, we're going to have a practical scenario of how to subnet a subnet. We're going to use this example. For example, we can use this as an example just to give you a better understanding. You are given the following network ID: 192.168.4.0. So this is a network ID /24. Our task is to create. Let's assume that your this is my restaurant that I opened. I want to create a subnet for my office. I want to create a different subnet for the kitchen. I want to create a different subnet for the public or the guests that come into the restaurant. So we have to create 3 subnets out of this principal subnet. So we list each network ID, subnet mask, host IP, host ID range, number of usable host IDs, and broadcast ID. So this is what we're going to do in the next, in our next lab, in our first lab for subnetting. So stay tuned. See you in the next video.